Welcome to every one of you to this research seminar in April. Tuukka, are you around at your, yeah.
Yes, I'm here.
Great. So it's a pleasure to introduce Tuukka, who will be giving us a talk. And I would just like to briefly introduce Tuukka before he starts his presentation. So he has a master's in radiochemistry and a PhD in environmental science, and he started working at the Radiation and Nuclear Safety Authority in Sweden in 1996 on the development of techniques for the removal of radon from drinking water. Between 2000 and 2006, he was responsible for gamma measurements of norm, as well as for the radon metrology laboratory. From 2006 to 2014, he was part of the environmental research team, and his work included ecotoxicology, radioecology, and safety research. Since 2015, he has worked as an inspector in the National Radiation Regulation Unit, and his responsibilities now include conducting research projects on natural radioactivity, as well as regulatory control of radon in waterworks and workplaces, and exposure from construction products. So, Tuukka, we are very excited to hear from you today, and you can go ahead and start to share your screen. I would just like to ask everyone else to also make sure their microphones are muted and the camera switched off while the presentation is going, and then we will have a discussion round after that. Over to you, Tuukka.
Thank you, Warren, and thank you for inviting me to give this lecture on spatial variability of radon in indoor spaces. Just a little minor corrections for the introduction is I work in Finland, not in Sweden.
Oh, sorry, my bad. We don't see your slides yet, Tuukka.
I'm going to.
Okay, great.
Yeah, entire screen, this big one, share. There we go. Can you see the first slide now?
Good.
Yes, thanks. This is the topic of my lecture today, spatial variability in indoor spaces. There's a big team behind this, myself. Volmar Kaipainen, he was a student of statistics who worked last summer at STUK. Then Katja and Maria, who are wizards in our databases. Olli and Päivi also assisted in these research projects. So how does this relate to RadarNorm project? It's a part of work package 2, which deals with exposure, and task 2.1, reducing uncertainties in radon measurements. We know that there are very good methods to measure radon, but radon sampling is the tricky one. And therefore, we have the subtask 2.1.1, uncertainty of measurements with passive active detectors, temporal and spatial variability. And in Finland, we especially needed more information on those. So let's first go to people's homes. And there are different types of homes where people live. These multi-dwelling units, we in Nordic countries usually call them housing cooperatives. So the purpose of a housing cooperative is to own and manage at least one building or a part of building, typically located on a single plot of land. So it means it can be a set of terrace houses, detached houses, or a block of flats. And the housing cooperative is the owner of the building or buildings on that plot, and is responsible for heating, electricity, data transmission, gas, water, sewage, ventilation, etc., meaning the technique what the house needs. Whereas the shareholder, they hold a certain number of shares which entitle to occupy an apartment in that housing cooperative. And the shareholder pays for the maintenance charge and covers these maintenance costs. Usually electricity and water are paid according to usage. The housing cooperative is responsible for practically all major renovations. Only the surface materials inside the apartment the shareholder or the tenant or the resident must maintain and renovate if necessary. Radon remediation and radon mitigation is nearly always belongs to the responsibilities of the housing cooperative. Therefore, the title in our published paper was Variation in Housing Cooperatives. Let's go to the background. Why did we do this? And why were we so interested in the variability of radon concentrations in housing cooperatives? Well, Stuk has been providing radon measurements since 1980s, commercial radon measurements. And quite often we see that in obviously a multi-dwelling unit, only 1 or 2 apartments were measured. Sometimes it was the order was made under the resident's name and from the resident's initiative, and maybe only 1 flat or 1 apartment was measured, or sometimes it was the housing cooperatives, but not every apartment was measured. So maybe they wanted to reduce costs. So what we know that the residents sort of extrapolate radon levels in their apartments based on the neighbors' measurements. On the right, you see a schematic of a housing cooperative with 4 different terraced houses, 1, 2, 3, and 4. And before the mitigation, radon concentrations in these 20 apartments ranged from 110 to 2,720. Here we see the 2,720 concentration. Here we see the 110. But we can see that just next door neighbors can have very different concentrations. Here we have 240 and here 2,060. We didn't have any quantified information on the variability of radon levels, so this was our goal in this research. The sample, as I told, we've been measuring radon concentration in Finnish homes and workplaces since 1980s. Our national radon registry contains radon concentrations from about 180,000 dwellings in Finland. And all these measurements, meaning measurements in homes, they have been conducted using our in-house track edge detector, Radonpurkki. And if somebody is interested to see what it looks like and how it performs, you can visit this underlined link. I don't know if these are distributed later, these slides, but there you go. It's a macrophore-based track edge detector. So we know the uncertainty and the quality assurance related to this method quite well. Then the multi-dwelling units or housing cooperatives were recognized by the plot number. Let's say there is a Lake Street 4, but under that address we have 4A, 4B, etc. So we know that it's a multi-dwelling unit or a housing cooperative. Of course, the plot may have been divided between 2 or more privately owned detached houses under a joint ownership agreement. This happens in big cities where bigger, older plots are divided into 2 so that more people can fit in. But we suspect that extrapolating radon levels based on the neighbors' results may occur also in such cases, and at least these cases are not that they are quite rare in our sample. So an apartment here is sort of a expanded interpretation. It can be a detached house, a semi-detached house, a flat in a terraced house, or an apartment in a multi-story building. So we filtered our data so that the measurements in the same apartment had to start within 30 days of each other. Quite often people measure with 2 detectors. So by doing so, we avoid before and after mitigation results. The measurement duration had to be at least 40 days so that the sampling is sort of sufficient. Measurement period had to be during our measurement season between 1st September, 31st May. Measurements in the same housing cooperative had to start within 100 days. This was a bit too lenient because more than 90% of the cases were started within 30 days or less. And if the apartment had been measured with 2 or more detectors, the geometric mean of the results was used for the analysis for indicating that apartment's radon level. After filtering, we had 3,500 housing cooperatives with almost 16,000 apartments measured. But the problem with our sample is, of course, that only few apartments on the first or higher floors were included in the sample, as we have always recommended measurements only for apartments facing the ground. In our national radon surveys, we have also measured higher floors, but I don't know if any of them were included in this sample. So all results from now on are applicable only to the apartments facing ground. The results. So we wanted to first see how radon concentrations are distributed in these housing cooperatives. And we performed Shaffer-Wilk tests on log transformations of the results, and we could see that nearly every time we could see log normal distribution.
Because parents decided to put it into
Is somebody asking something? I can hear.
I don't think that was just some background noise.
Okay, it's background noise. Right.
Yeah.
Okay. So here is the housing cooperative with 43 apartments measured, and here 31, and we can see that the QQ plots are quite nice. So we can conclude that geometric mean is a good estimate for the housing cooperative, and geometric standard deviation is suitable variable to describe the variability. GSD is multiplicative, thus relative by definition, and it makes easy to compare different housing cooperatives which may have different radon levels. Well, do radon levels influence variability? Of course, observed GSDs are not only representative for the variation in concentration, it also includes variation due to the detection technique. But as I explained, we know very well our detector, and here I show what are the random uncertainties related to the results and how we can estimate them. You don't need to understand anything about these formulas, but this is just to show that we use this in Monte Carlo simulations. So we simulated, I can't remember, maybe 500,000 times 2, 3, 4, 5, etc. radon concentrations, the GSDs in different levels, and we find that the range of a GSD due to the technique ranges from 1.04 to 1.27, depending on the number of measurements and radon levels. Then we subtracted the GSD from the observed GSD, and we got the GSD based on the concentration variation. Then we performed Spearman tests, and it appeared independent of radon levels, meaning we can group the sample by the number of detectors. Radon levels are not that important here. Then we started modeling the variability, probability distribution of 9 categories, 2, 3, 4, 5, 6, 7, 8 and 9, 10 to 14, and more than 15 at one go. We used Burr's distributions quantile function to fit the GSD data, and because at that time I didn't have a good computer, so I sort of model it with percentiles, not the empirical probability distribution. But this was quite easy. We could fit the Burr distributions parameters H and B with the logarithmic function quite easily. And then we could use Monte Carlo simulation for the model and compare true measurements to the simulations. Here we have, let's start here. Here is the interquartile range, meaning from 25th percentile to 75th percentile. And these are the model data, and these are real data observations. The error bars are the IQR, and also the median is here, the line, and then the diamonds are the measured medians. And the same for the 68% range, quite nicely. I was quite happy with this. And also the 90% range. Some deviation there, but nothing that bad. So we had a quite nice model, so we could go to probability calculations afterwards. So I considered this validated. Okay, let's first start with the resident's perspective. What is the probability that my apartment has higher radon concentration than the reference level of 300 becquerel per cubic meter? If I live in an apartment, in a housing cooperative with, let's say, 12 apartments, and the geometric mean concentration is, let's say, 100, so there's about 6% probability that there is too much radon in my apartment. So these were all computed from the model. But the situation changes a lot when we look at the housing cooperative's perspective. We remember that the housing cooperative is responsible for the radon mitigation or radon remediations. So what is the probability for the housing cooperative, for the house to have one or more apartments that have higher than the reference level radon? So we see now 100 becquerel per cubic meter geometric mean, and 8 apartments is already 35% probability. So this is really interesting how this changes from the point of view from the resident and from the housing cooperative. So what does this mean? But first, let's compare it to other data from other studies. We could not really find any comprehensive study or survey on housing cooperatives or multi-dwelling units where this GSD would have been determined. Well, our study, the main finding was that the median GSD depends on the number of apartments measured simultaneously. We, of course, don't know how many there are, but if 2 apartments are measured at one go, then the GSD median is 1.4. Whereas in large housing cooperatives, more than 15 apartments measured at one time, it's already 2. But I wanted to compare this to something. So Yarmoshenko has reported the 10 to 10 kilometer grid of European data, and ground floor rooms, the geometric standard deviation is 1.85. Interesting. This is different buildings, different apartments, houses in a 10 to 10 kilometer grid, and we are well within the same range. And in ICRU 88 summarizes 10 to 10 kilometer grid in ground floor rooms, and reports range 1.7 to 2.2 in different countries. So if we compare with this data, we see that if there are more than 7 apartments, we already are on the same level as the 10 to 10 kilometer grid. So this means the only conclusion from this is that extrapolation based on the neighbors' results is impossible. We have at Stuk we have published 2 guides in both national languages. Taloyhtiöiden radonopas, radonihusbolag. So meaning that it's a radon guide for housing cooperatives. And the key message is that the housing cooperative should coordinate the radon measurements in all apartments and other common living areas of the housing cooperative. New buildings have 10-year warranty in Finland. So if the housing cooperative is screened or initially investigated during that time, there's a warranty period, and if higher than reference level values are found, the builder must make corrective actions. The detector placement will be correct and documented if, let's say, a trained janitor goes and puts the detectors into the apartments. It's easier for the housing cooperative to remediate and plan the remediation as all spaces are already measured. Then it will help prevent disputes. Sometimes a resident measures their own apartment and finds higher than reference level value. And then the housing cooperative says that, oh, we want to wait till the next measurement season and measure other places in the housing cooperative and then plan the radon mitigation. And then the resident is very impatient and worried about the radon level, and then there is a dispute. And also, if some of the laboratories offer discounts if the orders are more than 10 detectors at the same time. And here is the link to our published paper. Yep, let's go to the workplace buildings. The 1991 Radiation Act required, or the ST guide, based on that basement and ground floor spaces are measured using 1 detector per 200 square meters. The later Radiation Act from 2018, also basement and ground floor spaces, 2 detectors for the first 200 square meters, and then 1 per 200 square meters. And all ventilation zones are dealt separately, meaning that there is a one blow, under one blower, the area of the building under one blower or a fan is dealt as a separate sort of building. And we start with these 2 detectors for the first 200 always. But still, we have large workplaces such as schools, sometimes reported only 1 measurement for the whole building. And also, municipal health authorities register had only 1 record for radon concentration, and they are the competent authority for public buildings and homes. And well, that has been changed later, but that was the misconception that 1 radon concentration applies to the whole building. Then my colleague Katja performed a survey a couple of years ago called Adequacy of Radon Measurements in Workplace Radon Surveys, and it revealed that 52% still, 52% of workplaces conducted the initial investigation with insufficient number of detection points or detectors. On average, 4.2 measurements were missing from the compared to our. This is actually not a recommendation. This is actually a requirement by the authority. This translates to a floor area of 840 square meters, which was left unmeasured on average. And we had not quantified spatial variability of radon in workplace buildings before, so we were also interested in that. So the sample, back to the National Radon Register. In December 2024, that's the latest what I know, we had 25,000 workplaces and 116,000 measurements from workplaces. Initial investigations always carried out with September 1st, May 31st, with minimum 2 months integrated measurements. We filtered the data by wanting the measurements to be conducted during the measurement season, duration at least 60 days. And if the measurement extended beyond May 31st, they had to end within 3 days from each other. Measurements began within 30 days of each other. And if multiple measurements were taken at different times, only the first results were included. Let's say there is a workplace measuring 2018, carries out radon mitigation and measures 2 years later, 2020. So we omitted the 2020 results These are on the first measurement results that we have. The above criteria were met at least by 2 measurement results. And so that left us with 18,421 workplaces with nearly 90,000 measurements. So let's go to the statistical key figures. Radon concentration in measurement points, we noticed that there are lots of measurements which were below the detection limit. As we can see from this, well, they were not normally distributed if we just think about the measurement points. But here we see these peaks. These are usually when the person who records the radon concentration into the register uses half value of the minimum detectable concentration. If it's 20, then she or he has put 10 here. So there are certain whole numbers which are overrepresented. So we can sort of jitter or simulate it to make it smoother. But anyway, we got the geometric mean about 40 and geometric standard deviation 3.7 from all the data points we had. And then if you look at the radon concentration in workplaces, just like in case of housing cooperatives, the radon concentrations within the workplace building, they were log normally distributed. So geometric mean was used for a workplace specific radon level and geometric standard deviation for the relative variability. And if we just put the workplaces and calculate the geo mean, it's again 40, but the standard deviation is a bit or clearly less, because now they have been averaged per workplace. Okay, so similarly to housing cooperatives, do radon levels influence variability? So here we have a bit more problem with this, because only half of the detectors are by Stuk. Radonova has provided 44% of the measurements, Alpha Radon 7 and Eurofins 1. But fortunately, Stuk, Radonova, and Alpha Radon, they all have very similar uncertainties at same measurement lengths and radon concentrations. So we use Stuk's uncertainty to subtract the GSD caused by the measurement technique from the observed GSD. And again, we performed Spearman tests, and that indicated that no statistically significant correlation could be observed between radon levels and the GSD, except for the case with 3 measurement points. What is that? All the other Spearman tests said that no statistically significant correlation. Sometimes the non-significant correlation was positive, sometimes negative, so it was like shotgun data. But then there was this one. Is it a fluke or what? Why would 3 detectors be special? Well, I considered it a coincidence, so I didn't mind, and I grouped the data according to the number of detectors used. Okay, here are the observed workplace-specific geometric standard deviations. Well, first of all, because in these workplaces where they had very small radon concentrations, we couldn't really measure the variability, because many of the results were below detection limit. So we only included those workplaces where the geometric mean of radon concentration was higher than 20. So we ended up with 13,190 workplaces. There was a clear correlation between the geometric standard deviation and number of detectors used. The median observed GSD ranged from 1.35 with 2 detectors to 2.78. This is already a very large variation when more than 30 measurements have been performed. There were lots of outliers. The GSD ranged from 10 to 90, and this accounted for 1.6% of the results. They were removed. Well, this 92 GSD was in a workplace where the other detector suggested 1070 becquerel per cubic meter, and the other was something like 1.6 becquerel per cubic meter. The latter is obviously wrong because we know the outdoor air already has something like 5 to 10 becquerel per cubic meter. So they are like all databases and registers. Our register is not perfect, and such results can be found. Interestingly, the upper limit, 5% limit, is somewhere between 4 and 5 for all detector, number of detectors. Okay, let's compute the probabilities. This is the simulated radon concentration distribution, cumulative probability distribution for workplace where the geometric mean is 200 becquerel per cubic meter, using 5 detectors or using more than 30 detectors. These are based on empirical data. As we see, if there's only 5 detection points, meaning most probably the workplace has a smaller floor area, notably smaller floor area, because they have only measured with 5 detectors. So this is more condensed. But when you have a lot of detectors and most probably a lot of floor area, the GSD data spreads. So we have a more smaller and especially more higher radon concentrations, even though the geometric mean would be the same, meaning 200 becquerel per cubic meter. Here we see that in this data, about more than 30, maybe 35% of the measurements are above the reference level of 300 if there are more than 30 detectors, but only 20 when there's 5 detectors. Let's look at how that affects the probabilities. This is the probability of workspace exceeding 300 becquerel per cubic meter. And here is the geometric mean of the workplace. But again, we have to look at it from the perspective of the employer. What is the probability that at least one workspace has higher than 300 becquerel per cubic meter radon concentration? And here we see already that especially in big workplaces, we have very high probability that one of them or even more are above the reference level. If we compare here 20 detectors, a single probability of your room where you work is 3%, but for the employer it is already like 1/3 or even more probability that something must be done. Not necessarily radon mitigation, but additional investigation as the ISO standard suggests. And this is, of course, always interesting to compare the results to other studies. What I found out that mostly the coefficient of variation was reported. So they had used arithmetic mean and standard deviation, and the coefficient of variation is standard deviation divided by arithmetic mean. This is interesting because our workplaces almost always were log normally distributed, so that's why we chose geometric mean and geometric standard deviation. But quite often it was the coefficient of variation. Only Ivanova from Bulgaria 2021 reported 16 schools where she recorded, or he, I can't remember, they recorded several measuring points on ground floor and calculated the median geometric standard deviation for them. In the 16 buildings, the range was 1.3 to 3.6, and the median was 1.8. So these are really quite nicely comparable to what we got. But as we can see here, these are much smaller variation, these two, than what we have found. Also, I think the number of workplaces in the analysis is we have much higher than the rest. But it's nice that it compares favorably to Ivanova's study. Well, interesting observations. My colleague Katja organized radon exposure concentrations in Finnish workplaces, which was a national survey of radon concentrations in Finland. It's a random sampling, sort of random sampling all over Finland. And from the results from that study, the unadjusted, so no ventilation correction, no seasonal correction, only integrated measurements, the arithmetic mean was 91, and the geometric mean was 41 Becker per cubic meter. The data in this present study, that is mostly from radon priority areas where radon measurements are mandatory. It is not often that employers from areas where the radon measurements are not mandatory voluntarily measure radon and furthermore send the results to Stuk. So mostly our radon register contains data from radon priority areas. But if we compare these two, 91 and 90.4, 41 and 40.2, practically the same results. And our radon priority areas are decided based on the concentrations measured in homes and workplaces, but because we have much more measurements from homes, actually homes dominate the decision which are priority areas and which not. So the criterion is 10% exceeds 300. But is this really justified for workplaces, because we get also the whole of Finland and radon priority areas exactly the same? Then we know that from our regulatory control of radon in workplaces, that 14 to 17% of workplaces who send results to Stuk, radon measurement results, there is one or more measurements that exceeds 300 Becker per cubic meter. If we compare this to the computed probabilities, we know that somewhere 40, the geometric mean in the workplaces, and maybe 10 detectors. So it is somewhere there, 14 to 17. It's between these figures. So that is also true. What are the key messages? We are coming to the end. Large variation occur in ordinary workplace buildings, and the investigated variation compare well to those observed by our inspectors. This doesn't mean that we are in crisis in Finland with our workplaces, so that the people are exposed in ordinary workplaces. No, in many cases, the reference level for radon exposure, what we use for workers, is not exceeded, because quite often we have hotspots in buildings, radon hotspots, that can be sometimes easily mitigated, and they are often visited rarely. And if so, facial mask can be used. But these hotspots quite often come sprinkler pumps, electrical enclosures, central heating system, wherever there are lead-throughs through the concrete slab, the foundation slab, there's a radon ingress into the building. But what we can learn here, it is very important to follow the instructions. 2 detectors for the first 200, and then 1 detector for the following 200 square meters, and carry out the initial investigation using enough detectors. This has already been taken into account in our regulatory control of radon in workplaces. There is a project ongoing where we are asking that, why did you only measure with 1 detector? Future work. As far as dwellings are concerned, we can consider this issue concluded and closed. Spatial variation has been sufficiently examined. Finally, I have a new computer, so I can carry out better simulations using true empirical distributions. Here, we just, for the workplaces, we used modeling to the GSD distribution. There is a finished report on workplaces. Again, you can click here and find it, but it was intended primarily as a data repository. A manuscript in English will be prepared next autumn and submitted to a journal. As you probably remember from the first slide, there's also the temporal variability. We have already submitted a manuscript called Short-Term Temporal Variability of Radon in Finnish Dwellings and the Use of Temporal Correction Factors. And today I learned that it has been accepted in Atmosphere, should be published quite soon. Then the year-to-year temporal variability project is ongoing. We have measured 3 consecutive years, and the 4th is ongoing. So next winter, I will prepare a manuscript about that. Unfortunately, that will be after the RadarNorm project ended. I want to express my thanks to the WP2 team of RadarNorm for their support. This is especially Sara from ISS. She has been great. And there's my email and telephone number. If somebody thinks of something to ask, you can always contact me later on.
Great. Thank you, Tuukka, for this excellent
then
talk.
I stop sharing, I guess.
Yes, let me quickly end the recording.